Today we're taking a look at lesson 3.4, which is all about dividing polynomials. In this lesson, they are focusing on two ways that you can divide polynomials. One way is going to be a lot easier than the other way, but again, you want to make sure that you understand both the long division method and then the synthetic division method. Long division is going to be very similar to this example that you're seeing right here on page 154. It's just like long division back in elementary school. It kind of behaves the same way. The steps are almost the same. So we'll kind of start off with just kind of remembering how to do a long division problem. Synthetic division, even though it kind of sounds more difficult, it's actually the easier of the two methods. You're using a lot less kind of ink on the paper. It's a lot less stuff to keep track of. It's kind of a more straightforward way of dividing polynomials. So we'll look at both methods when we start going through these examples. So if you think back to elementary school, looking at this one that's right on the page here, 83 divided by 6. So what they're doing now first is they start off with the tens place. Basically, just because this is 83, if you had a larger number, you'd always start off with that first digit all the way over to the left, the largest digit. So what you're asking yourself is how many times can 6 go into 8? How many times can 6 go into 8? Well, only one of them, right? Only one 6 can go into 8. So that's where that 1 comes from your quotient there. So 1 6 can go into 8. So 1 times 6 is 6. And then I just do the math. I subtract each step. So 8 minus 6 is 2. And then the next step is you bring down the next term in your divisor. You bring that down. So there's that 3 right there. So now I'm asking myself, since 6 can't go into 2, right? We already kind of did that step. Now we're looking at 23 as a whole. So how many times can 6 go into 23? 6 times 4 is 24. So I think that's too much. So only 3 of them can go in there. 6 times 3 is 18. So I put a 3 at the top as part of my quotient. 3 times 6 is 18. And now I just subtract the two numbers. 3 minus 8, I'd have to carry that over. So that's 5. And then 1 minus 1 is 0. So 23 minus 18 is 5. That's a remainder. It's basically like the leftover part. So 83 divided by 6 is 13 remainder 5. That's what that R5 means. So very similar to that type of problem. That's exactly what long division is going to look like, except for now you're going to have some algebra into it. You're going to see some X's. You're going to be, subtracting algebra throughout those steps, not just numbers. So for number 1, or example 1, use long division to divide these polynomials. So I think the easiest way is I'm actually going to work this out on a piece of paper instead of trying to track myself and work through this problem here. So I'm going to work this out on a blank piece of paper, and then you can follow along, or you can just kind of look at your book and follow along as well. So the problem is x cubed plus 5x squared plus 6x plus 9, and they want to divide that by x plus 3. So very similar to this example at the very top of this page. This is 83 divided by 6. So this problem is going to be x cubed plus 5x squared plus 6x plus 9 divided by x plus 3. So I'm going to write that out here. Divided by x plus 3. All right. And again, we're going to keep kind of going back to this example up here. Your first step is you're trying to figure out how many 6's can go into that largest digit there, which is an 8. How many 6's can go into 8? So I figured out one of them, right? So what I do is I put a 1 up top, and then I take that number, multiply it by what I'm dividing by, and then that gives me that number here. So 1 times 6 is 6. Same kind of process here, but again, you're dealing with algebra. So what I'm looking at right now are these two terms right here, that x and that x cubed. So I'm trying to come up with a number that's up here, right? Our first kind of number we're creating. And I'm asking myself, how many x's can go into x cubed? Just like over here, I asked myself, how many 6's can go into 8? Only one of them. How many x's can go into x cubed? Well, I think 3 of them, right? I can have 3 x's in x cubed. So what would I have to put up top here in order to multiply by x to be able to get an x cubed down here? Because whatever this number is up here, or whatever this term is, when I multiply it by x, I want x cubed. Because what that's going to eventually do, it's going to chip away, and I'll be able to cancel all these terms out, and I'll be left with a remainder at the end. So what I'm asking myself is, what times x will give me this first term here, x cubed? And that's going to be x squared. X squared times x is x cubed. But don't forget, it's almost like distribution, x squared times x, but I also have to do that 3 as well. So x squared times 3 is 3x squared. And now I subtract these terms. I'm subtracting this entire thing, both terms. So x cubed minus x cubed. Again, this is what we want to do. We want those to cancel out and get 0. And then I have 5x squared minus 3x squared, that's 2x squared. So then I bring down these other terms, plus 6x plus 9. And now I start again. I'm trying to think of what my next term will be. When I multiply it by x, it's going to let me cancel out this leading term down here. So what I want to be able to do is I want to be able to cancel out. I want to be able to subtract 2x squared. So I'm asking myself, what times x is going to give me 2x squared? The goal here is to always figure out what that product's, what I have to multiply that leading term by to give me this first term here. So what times x gives me 2x squared? Well, I think that's going to be a 2x. So 2x times x is 2x squared. And then again, just don't forget to distribute it to the 3. 2x times 3 is 6x. Remember, I'm subtracting that entire row. So 2x squared minus 2x squared is 0. 6x minus 6x is 0. 9 minus 0, if you want to think about that. But technically, we're just bringing it down. That's our next term. So in this case, there is nothing that we can multiply by x to give me 9, right? Nothing I can multiply by x to give me 9. So this is what they call my remainder. So my answer is going to be x squared plus 2x plus 9 divided by x plus 3. So that is my remainder. Some people also write it like this, which is perfectly fine to write it like this. X squared plus 2x, remainder 9. That's acceptable as well. But a lot of times, and I'm not sure how this book writes it, let's look at our problem. They write it as a fraction. So take a look at the bottom of page 154. Here's their answer. So they write it as x squared plus 2x plus 9 divided by your divisor, the thing you divided by. So this is a very popular way of doing it. You'll probably see it like this. When we go through here, this is the way I'm going to write it every time. But you might see it like this if you go through the internet and look at different examples. Some people will just write x squared plus 2x remainder 9. Either way is acceptable. All right, B. Same idea. I'm going to work through this step by step. I'm not going to kind of track throughout this thing. This example B is a very important example because what you're looking at here is you're looking at a problem 8x cubed plus 27. What you should be noticing here is you're missing terms. You don't have an x squared and you don't have an x term. Okay. When that happens, that's a big deal. You have to have what they call like a placeholder in for that. So this problem, 8x cubed plus 0x squared plus 0x plus 27. And remember, I've got to have those placeholders there. Otherwise, this whole long division process doesn't work. So if you're missing a term, you've got to have a 0x or a 0x squared. And I'm dividing by 2x plus 3. So I'm going to do the same idea that I was just walking myself through. I'm trying to think of some number up here, something, when I multiply it by 2x is going to give me 8x cubed. I always want to subtract. I always want to eliminate this leading term here. So I'm thinking, okay, well, what times 2 will give me 8? What times 2 gives me 8? Well, 4. 4 times 2 is 8. Remember, just like with long division, you're subtracting this stuff. And then I'm thinking to myself, what times x is going to give me x cubed? Remember, I want these two things to be exactly the same. So 4 times 2 is 8. That'll cancel out my coefficient. What times x is going to give me x cubed? I think that's going to be an x squared. X squared times x is x cubed. And if you look, 8x cubed minus 8x cubed is 0. Perfect. But again, don't forget you're multiplying not only just the 2x, you're also multiplying the 3 by that. So you've got to multiply both of those things in that binomial. So 4x squared times 2x is 8x cubed. 4x squared times 3 is 12x squared. And now I can subtract. 8x cubed minus 8x cubed is 0. 0x squared minus 12x squared is negative 12x squared. Then I'll go ahead and bring down my other two terms, plus 0x plus 27. And now I start back over. I'm thinking of something. When I multiply it by 2x, is going to give me this leading term down here. It's going to give me negative 12x squared. So what times 2x gives me negative 12x squared? I know that negative 6 times 2 is negative 12. So I'll start off with that. Negative 6 times 2 is negative 12. And then x times x is x squared. So x times x is x squared. Don't forget you're multiplying it by the 3 as well. So negative 6x times 3 is negative 18x. I'll subtract that row. Negative 12x squared minus negative 12x squared is 0. 0x minus negative 18x is 18x. Bring down that next term. And then I go back to the drawing board, trying to think of something when I multiply it by 2x is going to give me 18x. I know that 9 times 2 is 18. And I don't think I need any x's because if I had an x here, x times x is x squared, not just x. So I don't need an x here at all. It's just going to be a 9. So 9 times 2x is 18x. 9 times 3 is 27. When I go to subtract both of those terms, 18x minus 18x is 0. 27 minus 27 is 0. So in this case, I've got a nice answer. I don't have any remainder. So my answer is 4x squared minus 6x plus 9. No remainder. You don't need 0 divided by 2x plus 3. You don't need remainder 0. If your remainder is just 0, you just leave it blank. This might seem confusing. There's a lot of steps here, a lot of stuff to keep track of. Trust me when I say two things here. The more you practice this, the more you practice going through these steps and make sure that your answer's correct, the easier it'll become after you try, 6 or 7 of these things. Also, don't give up. The more times you do this, the more second nature it'll become, and you'll be able to knock this out here in just like 30 seconds. So you'll get quicker as you do these. Example 2. This is the second division. This is what they call synthetic division. You could see that they're trying to set you up here and show you how this translates from long division to synthetic division. So let me go ahead and get a blank piece of paper and I'll show you what they're talking about here. What is 2x cubed minus 7x squared minus 4 divided by x minus 3? The first thing I want to remind you of is example 1, part B at the top of the page. Remember, if you're missing a term, you've got to have that 0 as a placeholder. So the first thing that I notice is that x cubed is my largest degree. So I need to have an x squared, which I do. I need to have an x, which I don't. And then I need to have a constant, which I do. So because I don't have an x term, I'll have to have a placeholder of 0x here. So the way this works is by setting this up with synthetic division. This is what it ends up looking like right here, this part underneath that long division. And the way they're getting this information is they are getting they're taking the coefficients to all of these terms. So they're taking all the numbers that are in front of my variables. So they're taking the 2, the -7. Remember, we need a placeholder with x. So they're taking the 0, they're taking the -4. They're just using the numbers, not the variables. So don't include any variables here. So here's how it works. What I'm going to divide is this expression right here, 2x cubed minus 7x squared minus 4. So the largest degree is an x cubed, so the coefficient's a 2. So all I want is a 2, no x cubed, no variables, just numbers. The next term is an x squared, so the coefficient is a -7. The next term would be an x. There's no x term here, so my coefficient's going to be a 0. And then the next term is my constant, which is a -4. I draw this kind of little bracket here just to separate what I'm dividing and what I'm dividing by. Okay, so that is my expression right here. And then I'm dividing by x minus 3. So one thing I really want to point out is when you're dividing by x minus 3, you're not using a -3 here. You want to use what's going to make x minus 3 equal 0. So two things here. Your coefficient to x has to be 1. So for example, if this was 3x minus 3, I would have to manipulate that. I would have to solve for x. So that has to be a 1x. It already is, so we're good to go. And then always take the opposite of that number right there. So that's a -3. I want to use a +3. Okay. One way you can figure out what that number has to be, you can always take what you're dividing by, x minus 3, set it equal to 0, and solve it. I'll add 3 to both sides, and I get that x equals 3. So I'm going to use a 3 over here. Technically, what you're doing here is you're using the 0 in this problem. What's going to make that, what I'm dividing by, equal 0? So here's what I do. Here's the process. So synthetic division is what this is called. I want to drop down that first term. So that leading coefficient, I want to bring that down. And now what I'm going to do is multiply and add, multiply, add, multiply, add, over and over and over. Okay. So 3 times 2 is 6. That's going to go up here. 3 times 2 is 6. And then add. -7 plus 6 is -1. Start again. Multiply. 3 times -1 is -3. And then I'll add. 0 plus -3 is -3. And now I multiply. 3 times -3 is -9. And then I add. -4 plus -9 is -13. So for this problem, again, you're just multiply, add. Multiply, put that product there, add. Put that sum there. Multiply, put the product there, add. Put the sum there. Multiply, put the product there, add, put the sum there. And what they call this, that last number there, that's my remainder. So what this gives me, since I'm starting off with an x cubed, 2x cubed, right? That's the highest degree. What that tells me is that this quotient right here, this answer, this is going to be an x squared. This is going to be an x. This is going to be my constant. And again, that's my remainder. So that's how I piece it together. I started off with an x cubed. If I divided it by x minus 3, that means that that leading term here is an x squared, which means the next term is an x, which means the next term is a constant, which means the last term is my remainder. So my answer here is going to be 2x squared. That's a -1, so it's going to be -1x. That's a -3, so it's going to be -3. And that's a -13 as my remainder, so it's going to be -13 divided by x minus 3. I know it's x minus 3 because that's what I divided by in my original problem. So again, might kind of seem like a little bit of a kind of whirlwind to you right now, but the more you practice this, the better you'll get, the more you'll understand it. What I would encourage you, if you decide to do any extra problems that are in that extra practice section, just make sure you have the solutions manual out so you make sure you're getting the right answer every single time. And if you're doing these problems and you're not getting the right answer, please reach out to me, send me a picture of your work, and I'll be able to track it and see what your mistake is. So. All right, so let's see. Let's actually double check and make sure my answer was right. Make sure I didn't make any mistakes. So we're at the top of page 156. Looks like the answer they have here is 2x squared minus x minus 3 minus 13 divided by x minus 3, which looks correct. All right, example 3. Relate p of a to the remainder of p of x divided by x minus a. So what they're focusing on here to explore this question, take p of x, and they want you to use synthetic division to divide it by x plus 5. So let's go ahead and do that first. So p of x, there we are right here, x cubed plus 10x squared plus 29x plus 24. So if we set this up using synthetic division, you don't want any x's here. I'm just going to take the coefficient. So the first thing I'm going to do is check and make sure all my terms are here. The highest degree is x cubed. They've got an x squared. They've got an x. They got a constant. So I'm not going to need any placeholders. There's no zeros in here. We're good to go. So that's a 1x cubed. So I need a 1. That's a 10x squared. So I need a 10. That's a 29x, so I need a 29. And that's just a 24, so I need a 24. We're dividing this by x plus 5. Remember, what I want is basically the opposite of that constant. Another way you can think about it is take x plus 5, set it equal to 0, and solve it. Subtract 5 from both sides, and I get x equals -5. So that's what I'm going to divide by here. Using synthetic division, always use the opposite of that constant. So a -5. So synthetic division, again, that first step, make sure you set it up correctly. Let me give you 2 warnings. Make sure you're using the opposite of that constant. What I'm dividing by, this is x plus 5. Make sure you're using the opposite of that number. And the other thing is make sure you don't need a placeholder. Make sure you have all your terms here. If you have an x cubed, an x, and a number, and you're missing the x squared, you'd have to have a 0 in that spot. So those are the 2 things I really want to warn you about before we get started. Here's how it works. Drop that leading constant, that leading coefficient down below the line. And remember, this is just multiply, add, multiply, add, multiply, add over and over and over. So you're going to multiply -5 times 1 is -5, and then add. And then multiply, and then add. And then multiply, and then add. So when I do that, my synthetic division, remember we started off with p of x equals x cubed. That was that highest degree. So once I divided this, I know that this is an x squared, that this is an x, that this is a constant, and that this is my remainder. Okay, so my answer here, my quotient is going to be 1x squared, 5x, plus 4, and then a remainder of 4. So plus 4 divided by, what were we? X plus 5. So the book said use synthetic division the first time. That's what we're looking like after we do synthetic division. All right, so we synthetically divided that. We got a remainder of 4 basically at the end, right? And I think what they're trying to get at with this question, if I'm understanding the wording of it correctly, is using synthetic division, you can get a remainder of 4. Or if you took this problem, x cubed plus 10x squared plus 29x plus 24, and you evaluated it instead of dividing by -5, if you evaluated the function using -5, which is basically this, let's write this down. P of -5 equals x cubed plus 10x squared. So -5 cubed plus 10 times -5 squared plus 29 times -5 plus 24. That would give you the same answer of your remainder. So the connection here is evaluating your function using that number versus synthetically dividing your function by the same number will give you the same answer. It'll give you that remainder. So, you know, it depends on the problem they're giving you. Sometimes it's quicker to answer a very specific question doing one versus the other. But just kind of understand that if I take that cubic, I synthetically divide it by -5, it'll give me that quotient with my remainder. Or if I'm just looking for the remainder and that's all the information I need, what I can do is evaluate that function, that cubic. I can evaluate it using that same number and it'll just give me the remainder. Again, some information is, you know, this method using synthetic division will give you different information. It gives you the remainder, but it gives you the quotient as well. But just using evaluations of functions, you can just get the remainder. I think that's the relationship they're looking for with example 3. So concept here, we're on page 157. Concept, remainder theorem and factor theorem. So a couple vocab words, important to know this stuff. The remainder theorem states that if a polynomial is divided by x minus a, the remainder is p of a, which is exactly what we just emphasized with this problem here, that last example. I can take a polynomial, I can synthetically divide it, it'll give me a remainder, but it's the exact same thing as if I take that same polynomial and I evaluate it using that number. It'll give me the remainder, okay? So conversely, basically the opposite. That's kind of a fancy way to say the opposite. When P of A equals 0, so that's basically saying when your remainder is 0, we can show that x minus a is a factor. So for example, we'll try to use this thing. If I want to show that a number is a factor or like a 0 of that function, like if I went to graph it, it would be an x-intercept. I can plug in that number, evaluate it. If that number, if I evaluate that function, it gives me equals 0, that tells me that that is a 0 in my function. That's an x-intercept of that function. Example 4. Use the remainder theorem to evaluate polynomials. So they're giving you a real world example here. The population of tortoises on an island is modeled by the function p of x, where x is the number of years since 2015. Use the remainder theorem to estimate the population in 2023. So the first thing I'm thinking of, how many years passed between 2015 and 2023? That looks like it's 8 years later, which is the reason why they're synthetically dividing by 8. So they got that 8 because it's 8 years after 2015. So they use synthetic division using 8. You'll see they set this up the same way we did. It looks like they have an x cubed, x squared, x, and a constant. But remember, you're just using the coefficient. So that's a -1, bam. That's 6x squared, so there's a 6. That's 12x, so there's a 12. That's 325, so there should be 325. And remember the format of this, the way this thing flows is you always bring that leading coefficient down. You never do anything with that. That automatically comes down below that line. And then I multiply, add. So multiply, that gives me -8. Add, that gives me -2. Multiply, that gives me -16. Add, that gives me -4. Multiply, that gives me -32. Add, that gives me 293. So remember, using synthetic division with that number, what they're focused on here is that remainder, because that remainder is what the information they're looking for. They're not necessarily looking for the quotient here. They don't want to continue to do math. They just want to answer their question, which was use the remainder theorem to estimate the population, right? So the estimated population in 2023 is 293 tortoises. So like I said back when we were kind of going through this example with example 3, it depends on what you're doing. A lot of real world problems will just use the remainder theorem where you just have to plug in that number and it gives you that remainder, or you use synthetic division just to focus on the remainder. If you're actually just trying to just straight up do math and you're dividing two polynomials, synthetic division is the way to go. But they could have done this as well. You could have plugged in 8 into that function right here. So -8 cubed plus 6 times 8 squared plus 12 times 8 plus 325. And that would have given you the same exact remainder. So a couple of options there for you. And then example 5. Check whether x minus a is a factor of p of x. This kind of goes back to what we talked about a minute ago, saying that if you get a remainder of 0, that's going to be an x-intercept, a 0, a root of a function. And I think that's what they're looking at here. So they're giving you the polynomial p of x. They're telling you to divide it by x minus 6. So again, this is the way this works. Here's how you set it up. The two things I really want you to hear me about, because these are two common mistakes. I'm dividing by x minus 6, but I don't want a -6 here. You're always going to use the opposite of that constant. I also said back at the beginning that leading coefficient here, what I'm dividing by, that has to be a 1. I'm not sure if you'll see any where you're going to have to simplify this at all. You will in pre-calc or something like that, but it looks like these might all just be an x, not like a 3x or a 7x or something like that. So x minus 6, if I'm using synthetic division, I want to use the opposite of that constant, which is a +6. And then to set up synthetic division, it looks like the highest degree is x to the 4th. Looks like I've got an x cubed, an x squared, an x, and a constant. This is that second thing I want you to focus on. Make sure all of your terms are there. Look for your highest degree and make sure you have every subsequent degree following the highest degree. If you're missing an x cubed, just make sure you have a 0 there. If you're missing an x, just make sure you have a 0. You got to have that placeholder. So that's 1x to the 4th. That's -8x cubed. That's 16x squared. That's -23x. And that's a -6. So here's how we go it. You just bring that leading term down. That 1 just drops down below because that gives you a starting place. Now you multiply and then add, right? Multiply, 6 times -2 is -12. Add, that's 4. 6 times 4 is 24. Add, that's 1. 6 times 1 is 6. Add, that's 0. And that's the emphasis that example 5 is looking on. If you get a remainder of 0, that tells you that this number, this 0, this x minus 6, that's a root. If I went to Desmos and I typed this function in, you'll see that this function crosses the x-axis at 6. If the remainder is 0, that's giving you a root of your function. It's telling you where your function's crossing the x-axis. Like we talked about, you can do either one. It doesn't matter if you want to use synthetic division or plug something in. Plugging something in can be dangerous as well. If you've got a really big problem and you're typing into a calculator and you screw something up or you miss a set of parentheses, you can make a mistake, right? You'll see here, you're dealing with some kind of bigger numbers. Some people prefer it this way. Some people can knock out synthetic division super quick as well. It's really up to you, whichever method you want to use. Same thing down here. Let's just double check and make sure it all works the same. There's an x to the 5th. That looks like it's the highest degree. I don't have an x to the fourth, so that's why they have that 0 there. You've got to have that placeholder for x to the fourth. They've got an x cubed, they've got an x squared, they've got an x, and they've got a constant. Remember, if we're using synthetic division, you always want to use the opposite of that constant. So it's an x plus 3. So the opposite of positive 3 is negative 3. And now I can use synthetic division. Look over here, they're saying that common error. Don't forget to include that placeholder, that 0. That's super important. Bring down that leading term, multiply, that's negative 3, add, that's negative 3. Multiply, that's positive 9, add, that's positive 4. Just keep going, multiply, add, multiply, add, multiply, add. And what you'll notice here is that your remainder is negative 21. It's not 0. So what that tells me is if I go to Desmos and I type in this x to the 5th function right there, it will not cross the x-axis at negative 3. It doesn't have an x-intercept at negative 3. So because my remainder is not 0, that's telling me that this is not a root. On page 159, it's going through some summary of the two types of division here, also the theorems for remainder and factor theorem. So feel free to look through that, maybe, tab those things out, take a picture of them, write them down in your notes, something like that. So you can always go back and reference them. And now we will go to page 160 and start working on 15 through 31. So let's go ahead and take a look at all the practice problems. 15 through 18, those 4 problems, they want you to use long division. And on number 16 and 18, they do have a coefficient in front of what you're dividing by. It's a 2x and a 2x. They didn't show you that in the practice problems, but we'll go ahead and do them anyways. So for number 15, x cubed plus 5x squared minus x minus 5. X cubed plus 5x squared minus x minus 5. And that's going to be divided by x minus 1. So remember the way this works is I am looking for some term. When I multiply it by x, it's going to let me cancel out that leading term down here. So I basically need something times x that's going to give me an x cubed. That way when I subtract it, it's going to let me cancel it out. So something times x to give me x cubed, that's going to be an x squared. X squared times x is x cubed. But don't forget, you're multiplying both of these things in this binomial, both the x and the negative 1. So x squared times negative 1 is negative x squared. And then if I subtract x cubed minus x cubed is 0. 5x squared minus negative x squared, that's 6x squared. And then I'm going to bring everything else down, minus x minus 5. Now I start back over. I'm trying to think of something when I multiply it by x, it's going to give me this leading term here, 6x squared. I need it to be identical. So I know 6 times 1, because technically that's a 1 there. 6 times 1 is 6. And then x times x is x squared. So 6x times x is 6x squared. And then 6x times negative 1 is negative 6x. Remember, we're subtracting that entire row. So 6x squared minus 6x squared is 0. Negative x minus negative 6x is 5x. And then drop down that last term, that negative 5. What times x is 5x? That's going to be a 5. 5 times x is 5x. 5 times negative 1 is negative 5. If I subtract that, 5x minus 5x is 0. Negative 5 minus negative 5 is 0. So my answer here, my quotient, is going to be x squared plus 6x plus 5. 2x cubed plus 9x squared plus 10x plus 3. That's all divided by 2x plus 1. So I'll go ahead and write that over here, 2x plus 1. I may have misspoke a minute ago. I think when I was looking through here, I looked over here and I said, oh, that's got a coefficient and that's got a coefficient. I was thinking of synthetic division. That's the only one that has that restriction. If this was synthetic division, or you wanted to do these problems with synthetic division, you would have to make that coefficient a 1, but not with long division, because we can go ahead and work the problem out right now. So for number 16, you're thinking of something times 2x to give me this exact same term, 2x cubed. So what times 2x is 2x cubed? I think that's going to be an x squared. Double check me. X squared times 2x is 2x cubed. And then x squared times 1 is just x squared. And now I'm subtracting these two things. So 2x cubed minus 2x cubed is 0. That's your whole goal here. When you're coming up with this number up top here, that quotient, you're trying to make a quotient, or that term in that quotient, to be able to cancel out that leading term. That's the goal. Just don't forget, multiply that by 2x, but also multiply it by that 1, that binomial, because that gives you the next piece of information to kind of keep working on this problem. 9x squared minus x squared, so that's 8x squared. And then I bring everything else down, plus 10x plus 3. What times 2x is 8x squared? That's going to be 4x. 4x times 2x is 8x squared. 4x times 1 is 4x. If I subtract those two things, 8x squared minus 8x squared is 0. 10x minus 4x is 6x. Bring down that last constant. And then start back over. What times 2x is 6x? That's going to be a 3. 3 times 2x is 6x. 3 times 1 is 3. And then if I subtract that row, 6x minus 6x is 0. 3 minus 3 is 0. So I get a remainder of 0. So my answer for number 16 is going to be x squared plus 4x plus 3. Number 17. 3x cubed minus 2x squared plus 7x plus 9. Divide that by x squared minus 3x. Again, you're thinking of something, right? This first thing that you're looking for. You're thinking of what times x squared is going to give me this first term here, 3x cubed. So what times x squared is 3x cubed? That's going to be 3x. 3x times x squared is 3x cubed. 3x times negative 3x, that's negative 9x squared. Remember, I'm subtracting that stuff. So 3x cubed minus 3x cubed is 0. Negative 2x squared minus negative 9x squared is 7x squared. And then all that other junk comes down. And then start again. What times x squared is 7x squared? That's just a 7. 7 times x squared is 7x squared. 7 times negative 3x is negative 21x. I'm going to subtract all that stuff. 7x squared minus 7x squared is 0. 7x minus negative 21x, that's 28x. I bring down that last constant. I'm asking myself, you might think we have one more step here, but when you look at this, what times x squared is 28x? There's nothing, right? You're not going to be able to come up with something. The way I know that is because, first of all, there's nothing times x squared to drop that degree. When I multiply something by x squared, even if it's just a number, it's going to stay x squared. If I multiply something like x times x squared, that degree is going to go up to x cubed. I can't take anything, multiply it by x squared, and drop that degree down to x to the first. So once this part right here, once that has a lower degree than what you're dividing by, that this is your remainder. So this part right here is my remainder. So my answer here is going to be 3x plus 7. And because this is a positive 28x plus 9, it's going to be plus 28x plus 9 divided by x squared minus 3x. And then number 18, 2x to the fourth. There's no x cubed, right? That's missing. So it's going to be plus 0x squared, or x cubed. We've got an x squared minus 6x squared. There's no x, so I can put plus 0x. And then there's a 3 plus 3 divided by 2x minus 6. Now I wrote this like this. It just depends on how your brain thinks. Some people like to always do this, regardless if they're doing synthetic division or long division. They like to put those placeholders in right here. Some people don't, because in long division, technically you don't need them there, but some people do. So it's up to you if you want to put the zeros in. That way you don't have to remember, do I need zeros? Do I need a placeholder with long division? Do I need a placeholder with synthetic division? You can always, your go-to is just to put a 0 there, and it works just the same with long division. So you don't necessarily need them. You could have just divided 2x to the fourth minus 6x squared plus 3. Either way works. So I'm asking myself, what times 2x is 2x to the fourth? I think that's going to be an x cubed. X cubed times 2x is 2x to the fourth. X cubed times negative 6, that's negative 6x cubed. And I'm going to subtract this stuff. So 2x to the fourth minus 2x to the fourth is 0. This is that part where if you don't have those placeholders in there, you might lose track and actually do negative 6x squared minus 6x cubed. You might miss that those two things are different exponents, right? Because I couldn't subtract negative 6x cubed from negative 6x squared. They're different degrees of variables. So if you're asking me my opinion, I would always put placeholders in here. I have seen other people that will catch things like that. If this was my negative 6x squared here, they'd notice that those two are not like degrees. They're not like terms. So they would just write that down. I see people doing this way more often than not. So I would always recommend putting these placeholders in here. It's just way easier, especially at the beginning, to keep yourself straight. So 0x cubed minus negative 6x cubed, that's 6x cubed. And then I bring all this other stuff down. Minus 6x squared plus 0x plus 3. What times 2x is 6x cubed? I think that's going to be a 3x squared. 3 times 2 is 6. X squared times x is x cubed. And then 3x squared times negative 6, that's negative 18x squared. Remember, I'm subtracting these things. So 6x cubed minus 6x cubed is 0. Negative 6x squared minus negative 18x squared, that's going to be 12x squared. And then all the other stuff comes down. What times 2x is 12x squared? I think that's going to be a 6x. 6x times 2x is 12x squared. 6x times negative 6 is negative 36x. Remember to subtract both of these terms. 12x squared minus 12x squared is 0. 0x minus negative 36x, that's 36x. Bring down that last term. Again, here's that place where if you didn't have this 0x here, if you didn't have this placeholder, you might make the mistake of doing 3 minus 36x and not recognizing they're not like terms. You know, always recommend putting those placeholders in there. And then I'm thinking, what times 2x is 36x? What is that, 18? 18 times 2x is 36x. 18 times negative 6, give me a second. What is that? Negative 60, 48, negative 108. 36x minus 36x is 0. 3 minus negative 108, that's going to be 111. So remember, this is my remainder. So my answer, my quotient is x cubed plus 3x squared plus 6x plus 18. And that remainder is a positive 111. So plus 111 divided by 2x minus 6. '19, synthetic division. So hopefully those go a lot quicker, a lot less ink to use. So let me just emphasize something. Here's how I usually set these up. I'm dividing by x minus 4. So make sure you use the opposite of that constant. So I'm going to be synthetically dividing by positive 4. The highest degree here is x to the 4th. So that's a 1x to the 4th. The next thing is an x cubed, which I don't have one. So there's going to be a 0 there. The next thing is x squared. So it's a negative 25. The next thing is an x, which I don't have one. The next thing is my constant, which is 144. So that's all I have to write down to set up synthetic division. Remember, this first coefficient comes down, it drops below the line, and now I start multiplying and then adding. Multiply and then add. So negative 25, negative 9. Multiply and then add. And then multiply 120, 144. Negative 144, and then add. So just to bring up a point for number 19, if I took that quartic, that x to the 4th, if I took this and typed that into my Desmos program, because my remainder is a 0, I know that that quartic, that would pass through the x-intercept at positive 4. That gives me one of my x-intercepts, one of my roots, one of my zeros. So just a fun fact, don't forget that if your remainder is 0, whatever you're dividing by, that's going to give you an x-intercept. So for number 19, I started off with x to the 4th. When I synthetically divide it, it's just going to kick that down 1 degree. So when I divided that x to the 4th by x minus 4, it's just going to kick it down to an x cubed. And this is an x squared. This is an x. This is my constant. And this is my remainder. So let's set this together. That's going to be 1x cubed. It's going to be 4x squared. It's going to be a negative 9x. And then a minus 36. And because the remainder is 0, I don't have to write that. Just assume that the remainder is 0. So that's my final answer. So if you compare that to 18, right, a lot less ink. It just goes a lot quicker. Number 20, x cubed. I'm sorry, for number 20, they're dividing by x plus 5. So the opposite of positive 5 is negative 5. And then for my synthetic division, the highest degree is x cubed. They've got an x squared, an x, and a constant. So I'm not going to have any zeros for placeholders. So it's 1x cubed, 6x squared, 3x, negative 10, minus 10. Bring down that leading coefficient and then start multiplying and adding. So multiply, add, multiply, add, multiply, add. So again, I know if I went and graphed that problem, that cubic, it's going to cross the x-axis because this remainder was 0. It's going to cross the x-axis at -5. So I started off with a cubic, which means this is an x squared, so it's 1x squared. This is an x, so it's plus x. This is my constant, so it's -2. No remainder, so I don't have to put anything for that. Dividing by x plus 2, so I know that that synthetic division is going to be -2. X to the 5th, x to the 4th, x cubed. I'm missing an x squared, so you're going to have a placeholder there for that. I've got an x and a constant, so it's 1x to the 5th plus 2x to the 4th minus 3x cubed plus 0x squared plus 1x minus 1. Drop down that leading coefficient and then multiply and add. So multiply, add, multiply, add, multiply, add, multiply, add, and then multiply, add. So if I go to graph this function, this x to the 5th, because my remainder is not 0, that is not a root. It's not going to cross the x-axis at -2. I started off with x to the 5th, which means this is an x to the 4th. So it's 1x to the 4th. There are no x cubes. I don't have to write that. You could if you wanted to, but I'm not gonna. So 0x cubes, there's a -3x squared. There's going to be a 6x, a -11, and then this is my remainder. So plus 21 divided by, looks like I divided by x plus 2. You're dividing by x minus 3, so that's going to be a positive 3. X to the 4th, x cubed, x squared, x, and my constant, so I'm not missing any terms. My leading coefficient's a -1. Then my next coefficient's a 7. The next one's a 1. The next one's a -2. And then a -12 at the end. Bring down that leading coefficient and start multiplying and adding. So multiply, add. Just keep going. And then 90, what is that? 100, 111? Yeah. And then add. So that means my remainder is 99. So 22, I started off with an x to the 4th. So that means that this is an x cubed. It always drops at 1 degree. So that's an x cubed. So -x cubed, and then my x squared, and then my x, then my constant, and then my remainder. I divided by x minus 3. For 23, use synthetic division show that the remainder of f of x divided by x minus 9 is p of 9. So we'll go and start off with synthetic division. X to the 4th minus 6x cubed minus 33x squared plus 46x plus 75. You're dividing by x minus 9. So the opposite of -9 is +9. And then go ahead and set this up. So it's 1, -6, -33, 46, 75. So go ahead and start multiplying and adding. Multiply, add. And then add, what do I get? -6. Multiply, that's -54. If I add that, that's -8. Multiply, that's -72. And add, that's 3. So I get a remainder of 3. And then I think what they're wanting us to do is go ahead and evaluate that function using that same number, and we should get the answer of 3. Our answer once we evaluate it should be 3. So let's go ahead and do that. We'll take f of x and we're going to evaluate it using 9. So it's going to be f of 9 equals 9 to the 4th power minus 6 times 9 to the 3rd power minus 33 times 9 to the 2nd power plus 46 times 9 plus 75. I'm going to go ahead and pause the video for a second and do the math here and make sure my answer is correct. Okay, I went ahead and evaluated that function, f of x. I plugged in 9 and it did give you the remainder of 3. Just to emphasize why you would do one versus the other, sometimes you're just straight up doing algebra, so you need to divide that function. In this case, it's an x to the 4th. You need to divide that x to the 4th to get that x cubed. You might even have to keep going, divide the x cubed to get the x squared, and then divide the x squared to get the x. Sometimes you don't need that much information, and you can just evaluate the function by plugging in that input, typing it into the calculator, go into Desmos or go into any type of calculator on the internet, typing that in, and then just evaluating it to find that remainder. Okay. So either way works. It's just up to you, whatever information you're looking for. Number 24, use the remainder theorem to evaluate each polynomial for the given value of x. So that's exactly what we're going to do. So we'll go ahead and just synthetically divide these just because that's going to be the quickest and easiest. So for 24, using synthetic division, this is not like a divisor. It's not like it's x minus 5. It's not an expression like that. This is telling you that x equals -5. So that's exactly what I want to synthetically divide by, is a -5. Let me just emphasize exactly what I'm talking about here. There is a big difference between x equals -5 and x minus 5. Those are two different situations. This is telling me the exact number that I have to synthetically divide by. This is the expression or the zero of that function, the possible zero, where I have to take the opposite of that constant. So make sure you're paying attention there. So with synthetic division, we'll use -5 because that's what they want us to use. This is a cubic, so 1x cubed, 9x squared, 3x minus 7, -7. Synthetic division, drop that leading coefficient down and start multiplying and adding. Uh, 50, 35, 85. And if I add, that's 78. So my remainder is going to be 78 there. 25. Again, x equals 3, so that's what I'll synthetically divide by. 2x cubed minus 3x squared, 4x, 13. Again, synthetic division, drop that leading coefficient down, multiply and add. So my remainder is 52. 26, synthetically divide by -2. Negative x to the 4th, so -1. 2x cubed, so that's a 2. Negative x squared, so that's a -1. 4x, so that's a 4. And then 8. Bring down that leading coefficient, and then start multiplying and then adding. Eight plus -44, 36, -36. So my remainder is -36. Remember, you could use synthetic division just like we did for, what I'm set up with. I don't have a calculator in front of me. I've got my phone, but this is kind of difficult to plug those into a phone like this, right? Trying to plug that into your phone can be difficult, if not impossible. Especially with me, I might screw up and click the wrong button. And then guess what? After you typed in all that junk, if you click the wrong button down here, then you're done, right? You have to start back over. If I had a calculator at home, I could definitely do that a lot easier, but I don't. So instead of using the remainder theorem, this is what they were looking for here, just evaluating the function. So let me just emphasize this with number 24, taking this problem right here, this x cubed plus 9x squared plus 3x minus 7, what they wanted you to do with these was plug in -5. So -5 cubed plus 9 times -5 squared plus 3 times -5 minus 7. But again, what I did with synthetic division for me in this situation just works a lot easier because I don't have a calculator. It would give you the answer of 78. So if you plugged in -5 for 24, you would have gotten 78. Either method works, gives you the exact same information. It's up to you. 27. So x equals 4. So I'll go ahead and do 4 again. X to the 5th, so 1. -3x to the 4th, so -3. -2x cubed. 1x squared. -2x. -1. Multiply, add. So 4 times 1 is 4. If I add, that's 1. 4 times 1 is 4. If I add, that's 2. 4 times 2 is 8. If I add, that's 9. 4 times 9 is 36. If I add, that's 34. 4 times 34, 120, 136. If I add, that's 135. So my remainder is 135. Again, I think with the book, with reading the directions, the remainder theorem, what this is emphasizing for 24 through 27 is taking f of 4, because that's the number they give you, x equals 4, and typing that into your calculator or doing the math by hand. It's up to you. So it'd be 4 to the 5th minus 3 times 4 to the 4th minus 2 times 4 to the 3rd plus 4 squared minus 2 times 4 minus 1. And then type that in your calculator, do it by hand, type that in the computer. It's up to you, but it's going to give you the exact same remainder, the exact same answer. Is each given polynomial a factor? Is each given binomial a factor of the given polynomial? If so, write the polynomial as a product of two factors. So they're giving you p of x, and they're giving you what you want to synthetically divide that by, or long division. It's completely up to you. I'm going to use synthetic division. This is another opportunity where they're just looking for the remainder. If you think back to the example that they showed you, I don't know, a few problems ago, back in the examples, to see if something is a factor, again, you don't care about the quotient. You don't care about, after you divide it, that answer to that division problem. All you're looking for here is just the remainder. That's the only piece of information you need. So do you have to do synthetic division? No, you can use that remainder theorem that they looked at up here. Just saw that I'm off my screen. So let me get a blank piece of paper. And again, I'm going to use synthetic division. Plugging this in, I don't have a calculator with me, so I can do this with synthetic division a lot quicker. So my polynomial is 8x cubed, so I need an 8, minus 10x squared, so negative 10, plus 28x, so 28, minus 16. And you want to divide that by x minus 3. It's not x equals negative 3, so since it's a binomial x minus 3, you want to take the opposite of that constant. So the opposite of negative 3 is positive 3. So I'm going to synthetically divide by positive 3, drop that leading coefficient down, and start multiplying and adding. 30, 42, and then add 60, 70. And then multiply. And again, I'm not looking for a quotient. I'm not looking for that next, polynomial after I divide it. All I care about is that remainder. Let me remind you, if that remainder is 0, then that is a root. X minus 3 is a 0 in that function. If it's not 0, then it is not a product of that function. It's not an x-intercept. It's not where it crosses the x-axis. Unless I made a mistake, I'm not thinking we're going to get to 0, because 3 times 70 is 210. Negative 16 plus 210 is something other than 0. So right off the bat, I can say no, that x minus 3 is not going to be a factor of that polynomial. It's not going to be one of those sets of parentheses. It's not going to be a 0. So for 29, 4x to the 4th. So 4, negative 9x cubed, negative 9, negative 7x squared, negative 2x, 25. They want to see if the binomial x plus 4 is a root, is a 0. The opposite of positive 4 is negative 4. So if I do the synthetic division, and if this remainder, if that is 0, then yes, it is a root. If not, then it's not. So negative 16, negative 25, 100. That's 93. Ooh, this is not looking good. Negative 4 times 93, 360, 372. So negative 372. If I add, that's negative 374. And then again, at this point, I'm going to stop and say no, because negative 4 times 374 is a big positive number. 25 plus that number is not going to be 0. So right then, that's where I recognize this is not going to give me a remainder of 0. So I'm going to go ahead and stop there. Number 30, negative x to the 5th, so negative 1. I'm missing an x to the 4th, so I have to have a 0 there. 12x cubed, 6x squared, negative 23x, 1. I'm dividing by x minus 2, so that synthetic division is going to be a positive 2. Bring down that leading coefficient, and then start multiplying and adding. So if I multiply and add, and then obviously, right, multiply, add, multiply that, 44. If I add, that is not 0. So again, that is not a root. That's not going to be an x-intercept. Hopefully 31 is. Let's see an example where it is. So 31, 2x cubed, 3x squared, minus 8x, minus 12, and then 2x plus 3. Ooh, I think I'm actually going to switch this up. I don't know if I want to introduce you to synthetic division where your leading coefficient is not 1. It's not super difficult, but I don't want to throw one more thing at you. So I am not going to do synthetic division with 31. I think I'm going to go ahead and evaluate it, using that number. So if I want to evaluate this using a 0, I need to figure out what's going to make 2x plus 3 equal 0. So what is going to make 2x plus 3 equal 0? Subtract 3 from both sides. 2x equals negative 3. Divide both sides by 2. I get x equals negative 3/2. I changed my mind once I just said that. Now I am going to do synthetic division. And the reason why is because I still have to figure out what that x-intercept is going to be. I still have to figure out what that value is going to be. So if you wanted to use 31, if you wanted to use the remainder theorem, you can plug in negative 3/2. So here's the problem right down here, p of x. So it would be 2 times negative 3/2 cubed plus 3 times negative 3/2 squared minus 8 times negative 3/2 minus 12. Again, type that in your calculator. And if you get 0, then it is a root. It is a 0. It's a factor. If you don't get 0, then it is not a factor. So let's go ahead and just use synthetic division with this one. So I'm going to synthetically divide by negative 3/2. Now we're dealing with numbers. So again, if you want to put that as negative 1.5, you could. It's up to you. drop down that leading coefficient, and then start multiplying and adding. So hopefully this doesn't get super nasty. We'll see. -3/2 times 2, that's -6/2. -6 divided by 2 is -3. If I add, that gives me 0. Multiply, add. And then if I multiply -3/2 times -8, that is 12. And add, that gives me 0. There is an example where it is. So that tells me, because my remainder is 0, that tells me that 2x plus 3, that is one of my factors. That's one of my roots. Again, if I go to Desmos and I type in 2x cubed plus 3x squared minus 8x minus 12, it's going to cross the x-axis at -3/2. That's going to be a root.